Good morning everyone, this is Rushali. In my last sessions, we discussed about conditional probability, then Bayes theorem, and we also discussed about some previous machine learning algorithms. I have mentioned machine learning subject playlist link in below description box. In today's session, I am going to present the next topic, that is Naïve Bayes Classifier. So for this topic, you must watch my previous video, Bayes theorem. So let's see this topic. We will discuss following points in the session, that is about Naïve Bayes classifier, why is it called Naïve Bayes, then Bayes theorem, Naïve Bayes algorithm, their examples, advantages and disadvantages, and applications. So let's see one by one. The first point is about Naïve Bayes classifier. So what exactly Naïve Bayes algorithm is? Naïve Bayes algorithm is based on supervised learning algorithm. We discussed supervised, unsupervised and reinforcement learning algorithm in our previous sessions. So Naïve Bayes algorithm is one type of supervised learning algorithm and it is completely based on Bayes theorem. This algorithm generally used for to solving the classification problems. Suppose there is one particular data set and in this data set multiple features are given. So as per the features, you need to find out the product or you need to find out the particular object. So for this purpose, this Naïve Bayes classification algorithm is used. This algorithm mainly used in text classification, then object classification as per their features, and which includes high dimensional training dataset. Next point is Naïve Bayes classifier. This one kind of classifier, they classify the data as per their features, okay? And this is one of the most simple and most effective classification algorithm. That's why this is one of the most important algorithm in supervised learning techniques. Naïve Bayes classification algorithm helps to build a fast machine learning models and to predict the data in more easiest way or fastest way. So that's why this algorithm is used. The most popular example of Naïve Bayes algorithms are spam filtration. There is a spam mails are there in your emails, right? So emails are by default classified into the spam folder, into the inbox or into the sent folder, right? So this algorithm is used for this email generation purpose. Then sentimental analysis, text classification and classifying the articles. So for all this classification purpose, this Naïve Bayes classifier algorithms are used. The next and most important points, why is it called Naïve Bayes? Okay. So first, what is Naïve? So Naïve because it assumes that it is the occurrence of certain features which is independent of occurrence of other features. Let's take one example. Suppose there is a features, data set of the features. For example, color is red, then shape is spherical and the taste is sweet. So as per the features, you need to identify the fruit. Suppose as per this feature, fruit is apple, right? So this is a work of Naïve Bayes algorithm and this is called as Naïve, means multiple features are there and as per the features you recognize a particular object. And Bayes means this particular algorithm is completely depend on principles of Bayes theorem. We already discussed Bayes theorem in previous session. I have mentioned the link of that video in below description box. So Naïve means as per the multiple features or occurrence of certain features. And Bayes means it depends on Bayes theorem. Next. So just see here, this is a Bayes theorem. We use this formula for solving the equations or solving the examples by using Naïve Bayes classifier algorithm. So this is a Bayes theorem that we already discussed in previous session. So let's review here. Probability of A given that B. This is called as posterior probability. Means B condition is already occur. You need to find out the A. Then probability of B given that A means A event already occur. You need to find out probability of B. This condition is called as likelihood probability. Then probability of A means prior probability and probability of B means evidence, right? So A and B, these two events are occur. So this is called as Bayes theorem. So let's see how to use this Bayes theorem by using Naïve Bayes algorithm. So first see here, these are the some algorithm steps of this Naïve Bayes classifier formula. Now just see here in this formula. So as per their algorithms, the first step is you need to find out probability of A event. This is your first step. Second step is you need to find out probability of B. This is your second step. Third step is you need to find out probability of B given that A. And after adopting or after inserting all the values into this equation, you need to find out probability of A given that B. So this algorithm we used in Naïve Bayes classifier, and these are the algorithm steps. Next. Okay. Now see here, this is an example of Naïve Bayes theorem. So just consider that this is your training data set. This first image indicates your training data. So from this training data set, the first column is weather, which indicates your training data, and this is a play. This is your target variable. Okay. So in this weather, there are three types of weather is there. One is sunny, second one overcast, and third one is rainy. Three types of weather is there. So as per the weather, you will play in ground or not. Okay. Suppose sunny weather, no. Overcast, yes, you should play. Rainy weather, you should play, yes. So in this way, this data set is given. Okay. Weather, and as per the weather, this is your target variable. So let's start the example solving. The first step is you need to convert the data set into the frequency table. This is your first step. Okay. So see here, this data set is given. First convert the data set into the frequency table. So in frequency table, see here, this is a weather. Three types of weather is there: overcast, rainy, and sunny. And there is a no and yes. So you need to calculate how many yes is there and how many no is there in this data set. So let's see here overcast. Here overcast yes, then overcast yes second time, then here overcast yes 3, and overcast yes 4. Means for overcast weather, how many yes is there? 4. Similarly for rainy weather, you should calculate how many no is there and how many yes is there. See here, for rainy weather, yes, then again rainy weather, yes is here. So there are 2 yes is there, right? And no, how many no is there? 3 no's is there in this data set. So in this way, you need to calculate the frequency table. So from this 3 weather, this times of no is there in this data set, and these are the yes. Okay. So as per their grand total, there are 5 no present in this data set and 9 yes present in this data set. Okay. So this is your first step. Convert data set into the frequency table. Now second step. The second step is you need to create likelihood table. Okay. As per the frequency table, you need to calculate likelihood table to finding the probabilities. Okay. So see here, what is likelihood probability? Likelihood probability means probability of B given that A as per your Bayes theorem formula. Okay. So this is your frequency table, right? Now what is likelihood? See here. How many yes is there? 4 for overcast weather, right? And how total data is present? There are 14 data is present in this data set, right? Total 14. So from this 14, 4 is yes for overcast weather. So 4 by 14, 0.29. This is the likelihood probability of overcast. Similarly, rainy weather. Rainy weather, there are total 5 assumption is there. So 5 and total by 14. 5 by 14, 0.36. For sunny weather, total 3 plus 2. 3 yes, 2 no. So 5 by 14, 0.36. Right? So this is called as likelihood probabilities. So you should use this likelihood probability for solving the equation. Okay? And similarly, see here, how many no are there in this data set? 5 no is there. So from that 14, 5 no is there. Means probability of no is 0.36. And probability of yes, how many yes is there in this data set? 9. So 9 by 14, 0.64. Means 0.64 yes probability is there. Clear? So this is your second step. First step, create frequency table. Second step, create likelihood table. Now third step is you need to use Naïve Bayes equation. You should use Bayes theorem and put up all these values into the Bayes theorem. So let's see. Okay. Now see here, this is your third step. So our problem statement is players will play if weather is sunny. If there is a sunny weather, then players will play in ground. So you need to find out the probability of this statement, whether this statement is correct or not. Okay. So this is our problem statement. So as per our Bayes theorem formula, see, this is our Bayes theorem formula. So as per their Bayes theorem formula, put up this value into this theorem. See here, probability of yes given that sunny. As per our problem statement, sunny weather is there and will play means yes. Okay. So yes given that sunny, and put up this value into this formula. This is our formula, right? Now the first step is you need to identify the value of this equation. Okay. So see here, first probability of sunny given that yes. So sunny weather. So from that sunny weather, how many yes is there? 3 yes is there. So 3 and yes means total yes is 9, right? So 3 divided by 9. This is total yes and this is yes for sunny weather. Okay. 3 by 9 is 0.33. Next is probability of sunny. So for this sunny weather, how many total outcomes is there? 3 plus 2, 5. And total data set is 14. Okay. So 5 by 14, 0.36. Next, probability of yes. How many yes is there total? 9. So 9 divided by 14. 14 is total values present in data set. So 9 by 14, 0.64. So just put up these three values into our formula. See, 0.33 into 0.64 and divided by 0.36. So put up this value into this formula, Bayes theorem, right? 0.33 into 0.64 upon 0.36. So final answer is 0.60. So this is the probability of yes given that sunny weather, and the probability is 0.60. Similarly, you should find out probability of rainy weather and whether the condition is yes, and similarly you should find out the probability of overcast weather when the condition is yes. And from this all three condition, which is the highest probability? The highest probability is 0.60. Okay. So 0.60, this is the highest probability, and this probability is there when players will play if weather is sunny. So this statement is correct. So in this way, Naïve Bayes theorem is used according to the features or depend on the features that present in data set. Now the next one is advantages and disadvantages. So the main advantages of Naïve Bayes classifier algorithm is a fast and easy machine learning algorithm to predict the classes in dataset. It is used in binary as well as multi-class classification. So we already discussed this point in previous session. Then it performs well in multi-class prediction. In multi-class classification algorithms, these algorithms are used, and it is a popular choice in text classification problems. And the disadvantages is in Naïve Bayes completely depend on features, right? But sometimes features in datasets are unrelated or independent features are there. So at that time this Naïve Bayes algorithm can't work. Only dependent features are there or similar features are there. Only this time this algorithm will work. Now see here, there are the different applications classifier algorithms is used. For example, it is used for credit scoring in credit card system, right? There are multiple features and functions are there. Then medical data classification algorithm means as per the symptoms, you should find out the disease. For this purpose, this algorithm is used. Then object and face detection purpose. Then in email, there is a spam emails filtering. Then sentiment analysis. Then recommendation system, right? So for in Amazon, in Flipkart, there is a recommended products are there. Means what you have purchased previously. So as per your purchased history, they should see, they should give you particular recommendation, right? So for all this purpose, this Naïve Bayes classifier algorithm is used. Thank you. Keep watching, keep learning.